Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be learning about scientific notation. Our aim for today is how can we convert a very big or a very small number into scientific notation. Here are the steps for converting numbers into scientific notation. Step 1, we're going to move the decimal either left or right until you get a value in between 1 and 10. So the value that you get should be no less than 1, and it shouldn't be 10 or greater. And while you're moving the decimal place, you're going to count the number of times you moved that decimal point. Next, you're going to write down the new number without all of the zeros. Step 3, you're just going to write times 10 after that number. Now, back from step 1, you're going to take that number that you counted, the number of times you moved the decimal point, and you're going to write that as an exponent of the 10. So you wrote the number times 10, then you're going to raise it to the number of times you moved the decimal. Now, if you move the decimal to the left, that is going to give you a positive exponent. However, if you move the decimal place to the right, that is going to give you a negative exponent. Let's do some practice problems together. In practice problem number 1, we have 39,000. In this number, the decimal point is here at the end. Now remember, we need to move the decimal to get a value between 1 and 10. Since 39,000 is a relatively big number, we're going to move the decimal point to the left. And we're going to count the number of times we move the decimal point as per step 1. So 1, 2, 3, 4. So we move the decimal point 4 times to the left. Step 2, we're going to rewrite the number without all of the zeros. So our new number is 3.9. Step 3, write times 10. And then finally, step 4, we're going to raise the 10 to the power of the number of times we move the decimal point. 4. Since we moved the decimal point to the left, this 4 is going to be positive. So our final answer is 3.9 times 10 to the positive 4th. And we can box that answer off. For problem number 2, we have 1,570,000. We put the decimal point at the end, and we have to move the decimal point over until we get a value between 1 and 10. Just like in problem number 1, since we have a large number, we're going to move the decimal place over to the left. And we count the number of times we move it over. 1, 2, 3, 4, 5, 6. We move the decimal place over 6 times. Step 2, we rewrite the number without all of the zeros. So we write 1.57. Step 3, write times 10. And for step 4, we take the number of times we move the decimal point over and raise the 10 to that number. Since we moved the decimal point over 6 times, we raise the 10 to the 6th power. Once again, we move it to the left, so the 6 will be positive. Our final answer, 1.57 times 10 to the positive 6. Question 3 is a little bit different. Here we have a small number. The decimal points here, we have a few zeros, then we have 7614. This time we're going to move the decimal point to the right until we get a number between 1 and 10. We start here at the decimal point, and we count the number of times we move that decimal point over. 1, 2, 3, 4, 5. So we moved it to the right 5 times. Step 2, rewrite the number without all of the zeros. So 7.614. Step 3, right, times 10. Raise the 10 to the number of times you move the decimal place, so times 10 to the 5th. But here we have a small number, so we move the decimal point to the right. To finish out step 4, if we move the decimal point to the right, we have to make the exponent negative. So our final answer for question 3 is 7.614 times 10 to the negative 5th. For problem number 4, we have another small number. We have 0.0000000037. First step, we move the decimal point over until we get a value between 1 and 10. Here we're going to move the decimal point to the right. And we count the number of times we move the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we move the decimal point over 9 times to the right. Step 2, rewrite the number without all the zeros. So we have 3.7. Step 3, write times 10. And for step 4, we're going to raise that 10 to a number equal to the number of times we move the decimal point. So 3.7 times 10 to the 9th. But we're not done. We have a small number, and we move the decimal point to the right. When you move the decimal point to the right, as per step 4, that gives you a negative exponent. So our final answer is 3.7 times 10 to the 9th. Now you might be asking, aren't these two numbers exactly the same? Well, they are. The reason why we use scientific notation, because this 3.7 times 10 to the negative 9th is a much more manageable number than this number with all the zeros. It makes life easier when you're trying to input numbers into a calculator or performing any calculations. There's less room for error, missing a zero, when you write the number in scientific notation. For practice problem number 5, we have 214,000. First step, put the decimal point at the end, since there's no decimal point. And we have to move that decimal point until we get a value between 1 and 10. Here, we're going to move the decimal point to the left. And we count the number of times we move that decimal point. 1, 2, 3, 4, 5. So we move the decimal point over 5 times. Step 2, we write the number without all the zeros. So we have 2.14. Step 3, write times 10. And we raise that 10 to an exponent equal to the value of the number of times we move the decimal point. So 10 to the 5th. Since we have a large number and we move the decimal point to the left, we will have a positive 5 as the exponent. Our final answer, 2.14 times 10 to the positive 5th. Question 6, we have a small number. The decimal point's here, and we're going to move the decimal point over to the right until we get a value between 1 and 10. And we count 1, 2, 3, 4. We move the decimal point over 4 times. Write the number without all the zeros, 5.200. These zeros will keep because these are significant figures. They're put there to show that it's measured to this number of decimal places. So 5.200. Step 3 times 10. And step 4, raise it to the number of times you move the decimal point, so 10 to the 4th. But remember, we have a small number, and we move the decimal point over to the right, so our exponent is going to have a negative sign. So our final answer, 5.200 times 10 to the negative 4th. Question 7 is not too big of a number, but we have 21. We put the decimal point at the end. We're still going to move the decimal point over until we get a value between 1 and 10 and count the number of times we move the decimal point. Here, we only have to move the decimal point one time. Step 2, rewrite the number, 2.1. Step 3, times 10. Step 4, raise to the first power. And since we move the decimal point over to the left, it's a positive 1. So our final answer is 2.1 times 10 to the positive first power. Similarly, question 8 is a small number, but not too small of a number. But we still have to move the decimal point over until we get to a value between 1 and 10. And count the number of times we moved it over. 1. 1 time to the right. Rewrite the number, 1.0. Step 3, times 10. Step 4, raise to the first power. But since 0.10 is a smaller number, and you move the decimal point to the right, that means the exponent is going to be negative. So 0.10 in scientific notation is 1.0 times 10 to the negative first power. If we have a number already in scientific notation, we can write that number in standard notation. So for practice problem number 1, we have 1.09 times 10 to the 7th. What we'll do is rewrite the number, 1.09, and we're going to move the decimal point 7 times to the right. It's a positive exponent, so we're going to make the number bigger. So move it over 1, 2. Now we run out of numbers, but we can always put in zeros. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The decimal point will go here at the end. To rewrite that number, we have 1, 0, 9, and 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Put commas in to make it easier to read. So our number, 1.09 times 10 to the 7th, is really 10,900,000. We'll try that again with problem number 2. Problem number 2, we have 8.04 times 10 to the 8th. Rewrite the number, 8.04. And we have to move the decimal point over 8 times to the right. It's a positive 8, so that means this number is a very large number. And we count 1, 2. When we run out of numbers, we put zeros. 3, 4, 5, 6, 7, 8. Rewrite the number, 804, and we have 1, 2, 3, 4, 5, 6 zeros. Put commas to make it easier to read. And we see that 8.04 times 10 to the 8th is 804 million. And we box off our final answer. Here, for problem number 3, we have a negative exponent. So when we write the number 3.0061, we're going to be moving the decimal point to the left. Negative value for the exponent, that's going to make a small number. We move it over once. We'd run out of numbers, but we could put zeros there to hold the place. 2, 3, 4. So our final answer, when we rewrite it, 0.1230, 1, 2, 3 zeros, then you have 30061. So 3.0061 times 10 to the negative fourth is really 0.0003061. Since there's a negative exponent, there is going to be a small number as your answer. And number 4, we have a very small number. We have 6.860 times 10 to the negative 9th. Rewrite the number, 6.860, and we're going to move the decimal point 9 spots to the left. 1, put zeros if you run out of numbers. 2, 3, 4, 5, 6, 7, 8, 9. When we rewrite the number, 0.1234567 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 6860. So when we rewrite 6.860 times 10 to the negative 9th in standard notation, we see 0, decimal point, 806860. That's why we use scientific notation. This is a much more manageable number than this here. For practice problem number 5, we have 8.1 times 10 to the 6th. Once again, rewrite the number, 8.1, and we're going to move the decimal point over 6 spaces to the right. 8.1 times 10 to the positive 6th is going to be a large number, so we move the decimal point to the right 6 times. 1, 2, 3, 4, 5, 6. So our answer when we rewrite it, 810, 1, 2, 3, 4, 4 more zeros. Put commas to make it look a little bit easier to read. So 8.1 times 10 to the 6th is really 8,100,000. Problem number 6, we have 4.541 times 10 to the 0 power. Well, that exponent represents the number of times we would move the decimal point. That number is 0, so we don't move the decimal point at all. So our answer is just 4.541. It doesn't change. Problem number 7, 2.1 times 10 to the negative first. We write the number, 2.1. We're going to move the decimal point over 1 time to the left since it's a negative number. 1. Since it's negative, we're going to make the number a little bit smaller. So our final answer is 0.21. We move the decimal point once again, 1 time to the left. Our final answer, 0.21. And finally, question number 8, we have 9.9 times 10 to the positive first. So we write 9.9, and we're going to move the decimal point 1 time, but this time we're going to move it to the right since it's a positive exponent. 1. So our final answer is 99. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we learned how to write numbers into scientific notation. We learned that very big numbers end up with a positive exponent, and very small numbers end up with a negative exponent. Finally, we learned how to take numbers in scientific notation and put them back into standard notation. Thank you again for joining us. Hope you learned something today. Please join us again soon.